Well, here's a few examples just to illustrate things. Here's the expression 1, or the type of expression 1. Here's the type of expression 2. And here's the type of the resulting ternary operator using expression 1 and 2. So if we got an int array and an int array, then what you can do is take off the first pair of brackets from each expression, or rather the last pair of brackets of each expression, I should say, and then you're left with int array and int array. And if you ask what's common between those two, then it's going to be object, serializable, and clonable. And since object is a supertype of serializable, you don't need to include that in the least upper bound. So what you end up with is just serializable and clonable array, like that. So you can't, of course, remove the more than one pair of brackets, because otherwise you'll reduce this to a primitive, and you can't do that. Okay, so what about this A and D multi-dimensional arrays? What's common between A and D? If you look at this, A is just A by itself, D extends A. So pretty clearly, if we take off all these pairs of brackets, we're looking at A and D, then the answer is going to be A, and with all those brackets. That's pretty straightforward. What about D and C? D and C, what's common between D and C? Well, it's going to be A for a start, and D and C, well, we've got K here, K extends I, so I is going to be common as well, and it's going to be A and I is the type for the result. What about if we make these things into arrays, multi-dimensional arrays? Well, then you just make this thing into a multi-dimensional array, so it's not complicated about that. What about B and C? B and C. Well, B and C's got A in common and nothing else, so it's just A. You can see, of course, that you don't necessarily get an intersection type. It's quite often just a simple type. D, this D array and this K array thing. D and K. D and K have got I in common. Yes, that's the only thing in common is I. So it's I array basically, because you just pull these off, put it back on afterwards. J and C. J there extends I, C extends A, implements K, K extends I, so it's just I in common between J and C. About we make those multi-dimensional arrays, then you just make this side multi-dimensional array. About K, array, and B. So look, K, array, and B. Okay, now B implements clonable, and that's an array, and arrays all implement clonable and serializable and objects. So the only thing that's going to be common between that is clonable. That's clonable. That's the only thing that's common. What about if we make this into an array? Well, then we can pull a pair of brackets off each side, and we're left asking what's common between B and K array, and the same answer again is going to be clonable. So you get a clonable array when you put the bracket back on. And just K and B by itself. K and B have got nothing in common except, of course, object right at the top of the tree. So object is the only thing there, and that's about it. So it's pretty simple, really. So be careful about the types. Yeah, once again, I just warn you that the Sun reference compiler and the Eclipse compiler as well use compound types, of course, rather than the least upper bound, which is described in the Java language spec. That's it's not very good, really, because Java language spec doesn't mention compound types as far as I can see. so it shouldn't be using it, but never mind. It doesn't make any difference because the only effect is just sometimes put a redundant type in, and you'll get it if you've got two interface types. If you end up with a least upper bound having just two interface types, then you'll get objects thrown in. Otherwise, it's just same really, get the same answer. And you might see this in error messages. So if you get an error message that says the wrong type, it says you got a type mismatch or something, then it will sometimes tell you what the type is, and sometimes it will see this, and you think, why has it got object in there? It's not necessary. And I think that's about it. Well, this here is what comes next. These are all the really basic statements that make up, about 90% of Java programming, probably, something like that. And they're all really trivial and really easy to understand. There's nothing difficult about them. And then there's these down here, which are a bit more complicated, and I'm only going to cover those, just sort of skim over them. I won't go into a great deal of detail about them because they need some concepts which haven't really sort of covered yet, so I won't go into a lot of detail on this, but I will probably do enough to continue and then come back and do these in a bit more detail later. So that's the direction I'm heading in. So that's about it, I think.